5x squared minus 8x plus 70. My window's probably going to have to get set up here. I'll pick zoom 6 to see what we've got. Not much. I'm going to go into the table. Let's go. See what kind of numbers we have. Okay, so y is getting large very fast. Okay, and that's for the y's there. Window. Negative 100 to 100 and see what we get. Okay. Now we want to graph the derivative function. So I want the derivative for every single x value on here. I want a whole graph of them and have the calculator connect them all and show me the derivative function. So to get f prime of x, we're going to let the calculator do this for us numerically. So we're going to go to NDeriv. Give it the equation. I'm running out of room there. So we're going to type in x cubed minus 5x squared minus 8x plus 70. I used x's. And then I want to tell the calculator to do it for every single x value in the window. So instead of putting a single number there, I'm going to have it put another x there so the calculator knows to keep doing this for all of the x's in the window. So we'll go to y equals, come down to another equation. I want the derivative of my function, so I'm going to go to math, get that NDeriv. I have to tell it the equation, x cubed minus 5x squared minus 8x plus 70, comma, x comes next, comma, and because I want it to do all of the x's, I'm going to feed it x again, not just a single number. And I'm going to make the graph look slightly different by coming over here and making it that fat graph. And it takes time because it's doing all of those calculations, all of those symmetric difference quotients for all of those x values in there. Okay. So, looks like the graph is crossing 2 points here and here. So it scoops down here and over here, and then the other half of the parabola over here. Okay. Now, I wanted you to be able to tell me 3 things at the beginning of the notes here. Let's see, where are they? What's happening on the original function when the derivative is negative, when the derivative is positive, and when the derivative equals 0. So let's take a look at the zeros first. Grab another color. The derivative equals 0 here and here. Well, if you take a look at the original function, what's happening on the original function at those 2 spots where the derivative was equal to 0? hopefully you're able to tell me that here the original function was a minimum, and here it was a maximum. And think about, derivatives are slopes of tangent lines. Well, if I'm at a max, the tangent line is horizontal. What's the slope of a horizontal line? It's 0. That's why the derivative is 0. Same logical reasoning down here. If I'm at a minimum, the tangent line is horizontal, making the slope 0, so the derivative is 0. So the derivative is 0. So, if the derivative of some c value is coming out 0, then the original function had a max or a min. Then f of c was a max or min. Alright, one part down. So derivative is 0, the original function had a max or a min. Okay, I wanted you to be able to tell me what's happening on the original function when let's go with the derivative is negative. Well, if I look, here's my derivative graph. These are all positive y values here. They're all up. Same thing here. Here is where the derivative is negative. Right in between those two zeros, that corresponds to this part of the graph. So what's happening on this part of the graph right here? That's not happening out here and out here. Hopefully you can tell me this part of the original graph is decreasing all the way through here. The y values keep getting smaller, 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 until I reach this 0, then they keep going up. So, if f prime of your c value is negative, then the original function is decreasing through that point. So if I decrease, I will get a negative derivative. So then the last part, what's happening on the original function when the derivative is positive? Well, the derivative is positive here. These are all positive y values, and the derivative is positive here. So what's happening as we always read from left to right, what's happening on the original function here? All of those function values are increasing all the way through here. Same thing here. After it hits its min, now I start increasing again. So the third big idea is if the derivative is positive, then the original function, f of c, is increasing through that point. Okay, you took this home, this 3-3. I want you, this is going to be part of your notes, but I want to see if you can do it on your own. I want you to be able to go through 1 through 7. Based on the notes you just got done, normally I would hold your hand through this, but I'm going to try something different to see if you truly understand what's just in those notes. So, this comes in done as part of notes tomorrow, and we'll go over it together. And then the homework for after that will be Calc 3-3, page 87, 1 through 11, skip number 7. All right, have this done when you come in tomorrow.